Hello, I'm Zixin Chen. I come from South China University of Technology. Today, I will present our work, PointDC, Unsupervised Semantic Segmentation of 3D point clouds via Cross-Modal Distillation and Supervised Clustering. Firstly, what is 3D Unsupervised Semantic Segmentation? Here, the task is to train a 3D segmentation model without annotations. The success of various supervised methods lean on annotations, but it's impossible on laborious to label all meaningful points in a 3D scene. In order to break free from labels, we start to explore unsupervised methods. There are two core problems of unsupervised semantic segmentation. The first is how to learn abstract semantic concepts from unlabeled 3D data. Meanwhile, there's no previous unsupervised segmentation work for 3D industry for reference. So we expect to find inspiration from 2D unsupervised cases. A cluster method, deep cluster, introduced to the unsupervised setting. First step, deploy k-means on pixel features extracted by CNN to get k-cluster centers. Then utilize these cluster centers to obtain pseudo labels used to train CNN. Repeat the above two steps until convergence. The subsequent work, such as IIC, PICAE, improves segmentation performance through contrastive learning methods. For example, IIC proposes maximize the mutual information entropy between two different views of one instance. PICAE introduced the environment and the environment augmentations, which employ two branches of respectively, then use two branches of pseudo labels to cross-supervise. So intuitively, we extend the clustering pipeline to 3D, replace images with point clouds as input, but we empirically find that the performance on ScanNet is poor. This result shows the above methods do not learn semantic representations for segmentation. In our analysis, the methods of simply extending the clustering pipeline to 3D suffer from the following two problems. The first problem is cluster ambiguity. As a limited point cloud data, 3D features are inefficacy. For example, ScanNet has only 1,513 scene data, while image datasets such as Coco has more than 100,000 images. For this problem, we propose Cross-Modal Distillation that is their knowledge from image models. The second problem is irregularity ambiguity. Unlike the grid structure of images, the structure of point clouds is sparse and irregular. Point clouds with different sparsity contribute differently to clustering. To address this problem, we propose superversal clustering, which means that the samples involved in clustering are not point clouds, but superversals with local geometry information. Superversal is obtained by over-segmentation using geometry information of point clouds such as normal vector. The globe obtained from over-segmentation is treated as an independent unit to participate in. The next figure shows the framework of PointDC. Briefly, PointDC is divided into two steps. The first step is Cross-Modal Distillation. The second step is superversal clustering. Next, I will detail these two steps. As shown in the box, the step 1 is Cross-Modal Distillation. First, the feature of multiple views are extracted using a self-supervised 2D model. Then use the internal and external camera parameters provided by the dataset to construct pixel-to-point map. The pixel features are aggregated into vector space using the obtained map for knowledge distillation, thus distillation with MAC loads. With the above steps, we have a 3D model with semantic representational capability. The step 2 is the superversal clustering. First, k-means clustering is performed on superversal features to obtain the semantic centers. Second, the pseudo labels of point clouds are computed based on the class centers. Third, apply superversal pooling on pseudo labels so that the labels within each superversal are the same. First, the model is trained with these pooled pseudo labels. Next, repeat the above 4 steps until the model converges. With the above steps, the performance of a 3D model is further improved. Here, for quantitative comparison, we employ MLU for measuring the segment capability. We deploy 2D unsupervised semantic segmentation methods and 3D representational learning models as baselines. As we can see, PointDC achieves sort of results. Now I will present some quantitative results of ScanNet. The segmentation results of our model are significantly better than others. Thank you for listening to our presentation.